Okay, to finish up 7.2, we're going to be doing multiplying and dividing this time with radicals. Okay, so we're going to start off with multiplying. The problems that you're going to see, some of the basic ones that we already have seen. If you have the same index, square root of 3 times square root of 5, you can multiply the radicals. So this would be square root of 15, and then you would look to see if you could simplify that. Square root of 15, no factor tree can be done. It's not a perfect square, so that would be our answer. Okay? Same thing would work out if I ask you to do some distributive property. Let's do square root of 10. So distributive property is going to be done the same way. You're going to take that square root of 2 and multiply it through. X square root of 2 plus both square roots I'm going to multiply, square root of 20. And if you can do the factor tree or simplify anything, you have to. X square root of 2, that's not stay the same. I'm going to leave that x square root of 2. Square root of 20, that can be done with a factor tree. 2 square root of 5. And there's your answer. Okay? So if you can simplify, I expect you to be able to simplify. Okay? Some are just going to be a little more work than others. So here we have x plus square root of 3 and x plus square root of 6. This is still just double distribute or FOIL, however you want to, whatever you want to call it. Take the x, multiply that through. X squared plus x square root of 6. Distribute the square root of 3. And look at it and see what you can simplify. Nothing with the x squared. Nothing with the x square root of 6. And nothing with the x square root of 3. Now square root of 18, that can be done with the factor tree. So I'm going to simplify that to 3 square root of 2. Right. Now, one thing we looked at before were in chapter 6, we're multiplying conjugates, and when all the square roots and when we're dealing with complex numbers, imaginary numbers, all that simplified. That is going to be used a lot for division. So if we look at an example, x minus square root of 10, x plus square root of 10. Knowing that we have the conjugates here, the opposites, let's look what happens. Distribute your x, you get x squared plus x square root of 10 minus x square root of 10 minus square root of 100. And the nice thing that's happening here is a lot of our radicals are either going to cancel out or simplify. They cancel out. Square root of 100 goes to 10. X squared minus 100. Now that skill or knowing this is going to help us with our division problems. And what we need to remember is we should not have a radical in a denominator. So if I give you x plus square root 10 divided by square root of 2, we're going to have to rationalize the denominator. And we're going to do that by multiplying to get rid of that radical in the denominator there. So what can we multiply by? Square root 2, square root 2. Remember, that basically simplifies to a 1, so we're not changing anything. Multiplying by 1 does not change the problem. In the denominator, we get square root of 4, which simplifies to 2. And up top is when you have to do a little bit more work. Remember, you're distributing that square root of 2. So it ends up being x square root 2 plus square root 20. And you simplify what we can simplify. Square root 20 goes to 2 square root 5. And like I've been saying all the way since we were doing the quadratic formula, you should always break it up into 2 small fractions to see if you can simplify anything more. X square root 2 over 2 plus 2 square root 5 over 2. Nothing here, so that x square root 2 over 2 is not stay what it is. Here, we're going to have square root of 5. 2 over 2 simplifies to 1. So there's a lot going on in that problem. Okay? We had to rationalize the denominator, and we had to factor tree, break it up and simplify. So there's our final answer. Okay, let's do one more example here. So we have square root of 3 plus square root of 2, then denominator 5 plus square root of 6. Now, we can't just multiply by square root of 6 like we did over here, square root of 2, square root of 2. We need to multiply by the conjugate since we have a binomial. 5 minus square root of 6, 5 minus square root of 6. Okay, and how we're going to multiply it does turn into a lot of work. Okay, up top we're going to do the double distribute. Remember, everything needs to be multiplied here. So if we multiply that through 5 square root of 3 minus square root of 18 plus 5 square root of 2 minus square root of 12. So we do have some things we're going to need to simplify. We end up with 3 square root of 2 and 2 square root of 3. Okay, so we're going to have some like terms to combine here. We end up with combining the 5 square root of 3 minus 2 square root of 3 gets us 3 square root of 3. And here we have negative 3 square root of 2 plus 5 square root of 2. That's going to give us 2 square root of 2. Now, in the bottom part now, that's just our numerator. Again, this is going to take a little bit of time. Everything should cancel out, or at least all the radicals should cancel out or simplify. We should get a single integer down there. So if I'm going to multiply this one through now again with my FOIL, I'm going to have 25 minus 5 square root of 6 plus 5 square root of 6 minus square root of 36. And again, things should cancel out. The 5 square root of 6's cancel out. Minus square root of 36. That's actually a minus 6. Square root of 36 is 6. So we're going to get 19 as our denominator. 3 square root of 3 over 19 plus 2 square root of 2 over 19. I'm writing it as two small fractions to see if anything can simplify. Unfortunately, nothing can. 3 over 19, that's not stay the way it is. 2 over 19, that stays the way it is. Okay, so here's our final answer. So you really have to be careful with the division ones. Some of them, there is a lot of multiplying through. Okay? Make sure you're multiplied by the conjugate so all the radicals either simplify or cancel out. That's the key, and that's what you're going for. Okay? When it's a single term, we can just do our normal rationalize the denominator. Okay? So there are the last couple examples of simplifying radicals. We had multiplying and dividing. So make sure you're taking the time to practice these, and then you can move on.